point to ask, I'd say. Excuse me. Okay. It was my fond wish this time for this sem to explain the class with a presentation. I hope I can open my laptop, but by chance, if I can't, green chemistry, 3 of you have submitted. Now, if I request you, can you present it? It's there in the drive for me, actually. It's there in the class as well. Just by chance. Your PPT and my explanation is what I want. This is what somehow I wanted to do it, but of late I could not. Okay. So let me first conclude with composites, then we'll think about the green chemistry topic. Okay. So yesterday, hope you have realized that we have concluded the discussion on fuels. Okay. There we discussed the numericals part of it in past 2 or 3 days. There we focus mainly on the calorific value, okay, calculation of high and low calorific values, and we focused also on the calculation of air quantities required by weight and volume for complete combustion of a fuel. Okay, any one question from this topic is mandatory. That's what I want to tell. That's the importance of the topic, and I'm very keen that you should all gear up yourself learning that topic seriously. Okay. And one more point before I just jump into explanation of the topic today's topic. I also want to tell you that numericals on either alkalinity or estimation of hardness of water by EDTA method are again mandatory questions. Any one is compulsory in your mid and of course the final exam. Okay. So I'm actually, right from my heart, if I want to tell, I'm not at all happy the way things went with the calculations part of hardness and alkalinity of water. Okay. So whatever, uh, let me not be much fussy about it, but the idea is, um, please check with the numericals and make sure that you are confident solving them. Okay, that's what I want to tell you all. Okay, so I'll conclude the chemistry syllabus with the discussion about composites and green chemistry. Okay, uh, but before I conclude start my explanation, hope you realize that I discussed about the biodiesel in fuels topic. Okay, so in that topic I explained what it means by biodiesel, what is transfer esterification reaction, and how the production of that biodiesel is done, why it is called an alternate source, and all. Everything has been detailed. Please check. Okay, actually that biodiesel part, what all I have explained, is a part of this chapter. Actually, it's a part of the final chapter, materials chemistry, in which you have 3 chapters. One is biodiesel, one is composites, the other one is green chemistry. Okay, and hence is the discussion. Okay, so what are composites? Your friend has already explained. Okay, so I shall keep explaining the topic. Okay, and I shall give you the flow charts. So what is the first point you need to write in your book? And we shall start our discussion is, what are composites? Definition. Okay, keep writing the definition, and I shall discuss the contents in a while. So first dot is, composites are materials formed formed by combining formed by combining two or more formed by combining two or more compounds which retain their physical, chemical, and mechanical properties, which retain their physical, chemical, and mechanical properties in the final product. So composites are materials that are formed by combining two or more compounds which retain their physical, chemical, and mechanical properties in the final product. Okay. And composites are having three phases. Okay. Composites have three phases. Okay. What are the three phases that are there in a composite? The first one is matrix phase. First one is matrix phase. The second one is dispersed phase. And the third one is interphase. And the third one is interphase. Keep writing the flow chart along with them. Okay. Now, when we are discussing about these composites, okay, what point has to be remembered very clearly is that these are not individual materials, but these are formed by combination of two or more materials. But then, what should be clearly understood here is that the materials which are clubbed together or combined together do not react at all. Okay? These are the materials which never react. Rather, they keep their individual identity in such a way that the product contains a blend of all the properties of both the materials which are being used for making the composite material. To understand this, I'll have to tell you, now is it not a common experience for us that that I told you that our spectacles which we are using nowadays is it glass? No, it is no more glass. Rather, we will say it is a composite material. We will say fiber material, glass fiber. Fine, correct. Now, if I take that specs, okay, then if you just watch the mirror portion of it, okay, what we'll have, that glass is put into a frame, okay. So if my specs that I've chosen like this, then that is the outer frame, okay. Inside the material is very transparent, okay. I have a colored specs, okay, goggles. Fine. Now there is one material which is filling the entire one and in entire content, and the other one is present as a frame. The material which is forming the frame of that structure is nothing but the matrix phase. Okay. What is matrix phase? It is the frame of a composite material is matrix phase. And the internal filling is nothing but the dispersed phase. The internal filling is dispersed phase. And a material is used to make this internal dispersed phase and external matrix phase bind together. Okay. That is nothing but the interface. Interface is the binding material. Okay. Interface is the binding material. Okay. Interface is the binding material. Fine. Now this is the introduction to a composite material. Now I want to tell a little about this composite materials. Unknowingly or knowingly, composite materials are being used from the earlier times. Okay, almost nearly to the beginning of the civilization, these composite materials are being exclusively used for all practical purposes. Okay, for that matter, if someone tells you something, then the right thing that can be told is even our body itself is having all composite materials. Okay, so to give an introduction to this composite material, hold on. Now is my voice clear? Okay. Okay. Now to introduce you all to the composite materials, I need to talk a little bit of history of composite materials. Now in our body, bones are there. Okay. If you talk the structure of the bone, okay, it is made up of the calcium part, okay, and the mucus part of it, or the organic part of it, the muscle part of it, okay, which is actually one of the best example to describe about a composite material. Okay, so that's the one. So next one is in the construction industry. Okay, what concrete we use is actually is the best example for the composite materials. Concrete is a mixture of sand, gravel, cement, various inorganic components, and there water acts as a binder or the interface material, and hence is the best example for composite. Actually, in the construction industry, composites are very famous. The mud houses, which are being constructed from time immemorial, okay, from very old times, is again a composite material of mud and straw or clay, okay, which is being binded by water as the interface. Okay. Even nowadays, the TVs, the bikes we are using, the car bodies, etc., are all excellent examples of composite materials. One more important example of composite materials is the tires of the cars. Okay, the tires of the cars are the best examples of composite materials again. Okay, why? Tire is made up of rubber, carbon. Okay, carbon is actually a binding material. Okay, and also hardening material. Okay, and along with that, when you see the manufacturing of the tire, it includes all the fibers, okay, that fill the famous advertisement nylon, nylon zip, MRF nylon zip is something like that, okay, which actually describes the examples of composites. So understanding that, I'll conclude my introduction here. Okay, generally not asked as a question, but it is interesting to know about it. Okay, and hence is the discussion. Next, after understanding the three phases of composites, now I need to introduce you all to the first discussion, that is the matrix phase. Okay, so when I'm talking about the matrix phase, actually this gives the frame of the composite. Okay, so first point there is, it gives structure or frame to the composite. Okay, to the composite. That's the first point. Now, what's the second point? It is, I understand that now this is the frame. Now, what I have done, I wanted to have a beautiful mesh, okay, for my house to avoid mosquitoes. So, what I have done, I've taken one nice frame, okay, made up of some polymeric materials. Okay, so this frame or wooden frame, I take the wooden frame. This frame is nothing but the matrix phase of the composite. Okay, now what does the matrix phase gives? It retains the structure of the composite. It will absorb shocks, okay, and it will not allow the internal components of that composite material to get disturbed. That means it retains the stress and strain and will not allow distortion of the composite material with respect to chemical properties, physical and mechanical properties. What that matrix does, it absorbs shocks, it will not expose the internal contents to the atmospheric conditions, and it maintains the stability of the composite material. So is the importance of that matrix phase. Now that matrix can be made up of either ceramic materials, metallic materials, or polymeric materials, and hence the classification of composites depending upon the matrix that is being used for making. Okay, so matrix phase is also called as, it is also called as main or bulk structure. Main or bulk structure. Okay, and it maintains the dimensional stability. Okay, second point is maintains dimensional stability. Okay, third one is absorbs shocks, stress due to external mechanical forces. External mechanical forces and 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 avoids corrosion of the internal phase and avoids corrosion of the internal phase. Okay, that's about the matrix phase. Okay, now one more point to explain the matrix phase. Okay, hope you have written this. Classification. Okay. Classification of composites depending upon the matrix phase. Okay, so write along with me. Depending on the matrix phase, composites are classified into metal matrix composites, MMCs, polymer matrix composites, PMCs, and metal matrix and ceramic matrix composites. Ceramic matrix composites. CMCs. That's a classification of composites depending upon the matrix phase. Okay, metal matrix composites, ceramic matrix composites, and polymer matrix composites. Okay, next is the discussion about the interface. Okay. Okay, next one is the discussion about the interface. You can write a line. Interface is the separating or the binding material that is used in the composite. Okay, interface is the separating or the binding material that is being used in a composite material. Okay, like water is the binding material. Okay, for cement. Fine, that's how you can just write about the interface. Okay, next one is classification of composites is further done depending upon the dispersed phase. Okay, so let me give an introduction to all of you about what it means by dispersed phase. Dispersed phase is also called as reinforced phase. Dispersed phase is also called as reinforced phase. Okay, reinforcement or reinforced phase is the dispersed phase that is present in the matrix. I'll get back to my example. I wanted to make a mesh door for my house. So what I have done, I've taken a wooden frame, okay, and I've made the, I've kept the mesh here. Okay, mesh is metallic in nature. Okay, whereas wood is the frame. Okay, so the filling that is obtained is nothing but the dispersed phase. Okay, like the way we put colors to various drawings kids would make, the filling portion is called as the dispersed phase. Okay, so what's the first point that can be written? This gives body to the polymer. It gives the body of the polymer, of the composite, sorry. It gives the body of the composite. Okay. Next, what is the important thing is this being the main component that is generally being used, okay, it imparts the required properties of the composite. Okay, and classification of composites depending upon the dispersed phase is into the following types. Okay, I'll write here dispersed phase, and the classification of the polymers depending upon the dispersed phase is into four types. The first one is fibers, and the composites are called fiber reinforced. Reinforced means filled or the dispersed phase. Fiber reinforced composites. Okay, and they are commonly called as FRPs. Okay, the bodies of all our gadgets at home are fibers. Okay, the second one is particulates. The second one is particulates. The third one is flakes. And the fourth one is whiskers. Whiskers are the four types of reinforcements that are being generally used, and hence the classification of polymers depending upon the dispersed phase. Okay, if the dispersed phase is fibers, the composite is called as fiber reinforced polymer, fiber reinforced composites, fiber reinforced composite, FRCs. Okay, if the particles are the filling materials, then particulate composites, flake composites, and whiskers. This is about the classification of composites depending upon the dispersed phase. Okay, and hence is the discussion. Now next, I'd like to introduce you to the further discussion about the dispersed phase. Okay, the dispersed phase is now a fiber. Okay, and I need to tell you a small example. Actually, when when I was your age, whenever there used to be dharnas at the campus and college, students used to pelt stones onto the windows and panes of buses. Common thing we used to see. And what they used to do, just pelt stones. Of course, the glass frames of those buses or the vehicles or the lorries would break and everything would come to the halt. Nowadays, if you pelt a heavy stone onto the uh, screen of the bus, will it break just like glass? No, never it will, because it is made up of PMMA material, polymethyl methacrylate material, flexigas material. Okay, it is a fiber now. Okay, and actually you'll be surprised. PMMA is actually a thermoplastic material, but the huge frame in front of the bus, okay, screen, is a composite material. That's the reason why it exhibits the properties of a thermoset polymer. Okay, so that main frame, uh, this PMMA is filled along with the dispersed phase, that is binder gum. Okay, and they'll fabricate the huge structure there. Okay, so I'm filling fibers into the matrix of the polymer. Okay, the fibers can be made up of many materials. Okay, the fibers can be boron fibers, aluminum fibers, okay, aramid fibers, only carbon fibers. Very important applications of composites begins with this. Okay, so these fibers can be made up of glass, carbon, aramid, aluminum, boron, etc. Okay, and hence is the classification. Hope you are able to understand along with me. Okay, so further classification of dispersed phase composites is fibers, particulates, flakes, and whiskers. Okay, I'm giving flowcharts and explaining the concepts to you. The fibers that are used can be organic in nature, inorganic in nature, or metallic in nature. Okay, and hence the classification of the fibers. So the fibers used now, fibers as reinforcement, that is dispersed phase. Fibers as reinforcement, if you are suggesting, then you are getting fiber reinforced composites, FRCs. Okay, the fibers can be made up of metals. Okay, they can be made of inorganic fibers, or they can be organic in nature. Okay, fiber reinforced can be metallic, inorganic, or organic. Or it could be like organic fibers. Okay, it could be aramid fibers, and it could be the polymeric materials like PMMA, PS, etc. Inorganic can be carbon, aluminum, carbon, okay, and various other components of carbon, okay, and glass, okay, glass is the main example. Metallic fibers can be simple metals like boron, boron fibers are used, copper fibers are used, for umpteen applications. Whether you're taking inorganic materials, the major ones are glass fibers, and carbon fibers are very much in use. Okay, organic polymeric fibers, umpteen examples. Major ones are aramids. Okay, they can be polyesters, various polyamides, or it could be various thermoplastic fibers. Like PMMA, and hence is the classification of the reinforcements. Okay. The fiber reinforcement can be made up of metal, inorganic materials, or organic materials. If they are metals, aluminum, boron are major ones. Copper, nickel, tungsten. Nowadays, for cutting tools and all, they are using tungsten fibers, titanium fibers for the purpose. Very small edges, they'll make a composite. They'll make for the cutting machines. Inorganic fibers. Best examples are glass and carbon. You know, there was a point of time this carbon fibers, it was made into a costume, and because it is very benign, they actually wanted to do some studies. Okay, and hence was the discussion. As very good conductors, carbon fibers used very much for high-end engineering applications. Aramids like the Kevlar. Aramid best example is Kevlar, which is used for bulletproof jackets, mudguards, or those helmets, etc. Aramid fibers. Best example is Kevlar, and it is used for the bulletproof jackets. Now, whenever the VVIP vehicles are going, okay, one interesting thing for EC students is the jammers they use. Is it not? If VVIP vehicles are going, okay, Z class category protection is provided, then you know that how they'll not allow the signals to get transmitted. So that huge vehicle, the jammer first goes, okay, followed by the huge rally of cars and vans that are just going. And what you'll realize that nowadays the prime ministers or chief ministers will be sitting in those bulletproof area. Okay, the screens are put. So what they are made up of? Kevlar. Kevlar is the main material that is used for making bulletproof composite. Okay, because of its toughness. They can wear the bulletproof jackets and they can make the screens of it. Everything is a composite material. Of course, along with that, polyesters are being used, polyamides are used. Just now I've told you, the screens are made up of a combination of PMMA and Kevlar as the fibers. Okay, for transparency, they'll use PMMA, and for the strength, they'll use Kevlar. And hence, is a classification of the composites depending upon the reinforcements that are being taken. Okay, but one more classification is there. Okay, now one more classification is the fibers can be a very long fiber or it can be a short fiber. Okay, so if the fiber is long, then it is called long continuous fiber reinforced composite, or the fibers can be short fibers. It is called short discontinuous fiber reinforced composite. Okay, so the fibers can be long and continuous, The fibers can be long and continuous, or it can be short and discontinuous, and hence is the classification. So all these fibers can be long and continuous or short and discontinuous fibers. Fiber reinforced composites, and hence is the classification. So when you're saying the fibers, now what are fibers? I already explained this to you. Fibers are materials. I've told the classification of polymers also. Okay, so what are fibers? These are materials which are having very good aspect ratio. Okay, having very good aspect ratio. What is aspect ratio? Equal to length to diameter. That means length to diameter. So what you'll realize, fibers are those materials which are very, very long and very, very thin, but they have very good, very high tensile strength. Okay, that's the reason why we make ropes with fibers, nylon fibers, even jute fibers and all, and we'll hang weights. Why? Their load bearing capability is very high. That means they have excellent tensile strength, and that means the load and load bearing capability. Okay, one more important point you should know is that when stress is applied on these polymers, will they suffer any change in the dimension? No. Such polymers which are not suffering any change in their physical structure by applying external stress are called fibers, whereas those polymers on which external stress is applied and the physical deformation takes place, and the physical deformation is permanent, plastics. If the physical deformation is temporary, they are called rubbers. Correct? I explained all this to you all, so I'm not extending the discussion. So that's the importance of fiber reinforced composites. Today's polymeric world is dictated by FRCs, fiber reinforced composite materials. Back at our college, this is one of the important thing many of the mechanical engineering people are nowadays taking as their projects. Okay, even as an interdisciplinary aspect, many EC students are now what they are doing is they are developing such small electronic circuits. Okay, and they want to put it in such frames which are having a lot of popularity or good importance. For fabrication and all, you also need to have a little bit good idea about this FRCs, fiber reinforced composites. Okay, that's the classification of composites on the dispersed or reinforced phase. Okay, next is the classification of polymers depending upon the particulate size. Okay, particulate reinforced composites is the next point of discussion. Okay, so what I've told, dispersed phase has four categories again. One is fibers. So fibers are long drawn structures that can be made up of metal, inorganic materials like glass or carbon, and organic materials, what all I've told with you. Okay, again I told you the power transmission lines what we are using for supply of electricity are all composites made up of aluminum. There the aluminum is used as the base material and copper is also combined with that to increase the conductance. So wherever they want composite materials which have to conduct current, they'll use metal fibers for the purpose. Okay, also carbon is used for the purpose. Okay, and hence is the discussion. Next, classification of composites depends upon the particulates or particles. Okay, so particulate dispersed composites. Particulate dispersed composites is the second subject of discussion. So particulate reinforced composites can be again of two types. Okay, large particulate dispersed or reinforced composite. They'll not say small particulate, they will not tell. They'll call it as dispersion strengthened composite. Dispersion strengthened composite is the next discussion. That's the classification. Particulate dispersed composites are of two types: large particulate and large particulate reinforced composites. They'll not say small, they'll say it as dispersion strengthened composite materials. Okay, large particulates are those particles which are larger in size. Now come on kids, I have one thing to tell you all. Do you know about the Cheetah Flooring? Cheetah Flooring, sometimes when we go out, we'll see the floor has different colors. Okay, then large particles you can see. Even in our houses, the granite flooring or flooring we are seeing will have a big conspicuous ones. Okay, like that, if you imagine a composite, the matrix is made and it is filled with little bigger conspicuous fillers. This filler is the reinforcement. Okay, and because it is a particle, small structures, it is called particulate. Okay, and that is filling the main frame of the composite material. That can be a large particle. Best example here is carbon black used in tire manufacturing. Okay, now in tires making, okay, rubber is vulcanized rubber. Okay, but the strength of rubber is depending upon the percentage of sulfur. Along with sulfur, okay, we'll add carbon. The black colors of tires is because of carbon as a pigment. But the carbon size is good, such good that it will not only bind, give color, but it binds the materials of the tire. So it is acting as a large particulate filler and also a coloring pigment. This is the best example to tell you all about the large particulate composites. Actually, there are other things like for high-end engineering applications. Now, I'm not extending my explanation because it is of less importance to EC students. Now, they want to fine cut the metals. Metals ni cut cheyali. Chala strong metals untai. Okay, such strong metals that they can't be just cut like that. Okay, so how to cut those metals? The cutting portion, the tip is made with very tough metals like titanium carbide, tungsten carbides and all, which are again a composite materials which are having large particulate structures. Their metals are being used. Okay, and the examples is cermets. They are called as cermets. I'm not extending that at all, kids, because it is of less importance to all of you. Okay, Next one is small or dispersed strengthened composite materials. So fine filling material is used in this case, and it can be anything. For example, is here the particulate size is small. Okay, small or fine particles are used. And my song of aluminum oxide is dispersion strengthened. Example, aluminum oxide is dispersion strengthened composite filler or particulate. Particulate used in aluminum matrix for wires for power transmission. As simple as that. That's the example of dispersion strengthened. Very nice examples. Large particulate tires, you remember, and dispersion strengthened aluminum oxide. Generally, they have never asked this question much. Okay, and hence is the discussion. Okay, next. Last classification of composites depending upon the sheets. Okay, when sheets of composites are being used, okay. Now, flakes and whiskers, I won't discuss much because flakes are the particulates which are having two-dimensional structures, okay, and they are used mainly for only commercial applications. Their utility is less. Whereas whiskers are those particulates which are having crystalline structure. They are crystals that are being grown and they are only used for scientific applications. Okay, so not much discussion is there on the flakes and whiskers. Okay, flakes are bidimensional, okay, having commercial applications, whereas whiskers are having a crystalline crystalline dispersed materials which are having more scientific applications, not very commercially being used. Whiskers, flakes are being used, of course, for the purpose. Okay, that is the discussion. Okay, the last classification of the composite materials is next one is about structural composites. Structural composites. Okay, this structural composite classification is depending upon the end product of the composites that are being made. Okay, the structural composites can be laminar or lamellar, layer-like. Layer-like, or it can be sandwiched composite. Okay, so it's a common thing. Nowadays, we are getting our doors, our UPVC panels. Now we are saying that now the windows that are being used are UPVC. Okay, polyurethane PVC compounds. Okay, UPVC they are saying, and they are saying these are being generally used for the making of our windows, panels. Okay, our modular furniture. PVC again, such is the application nowadays, okay, of the polymeric materials. Now, if I'm using them as sheets, it's a common thing. The composites, particularly that has replaced the wooden cutting down of trees one is minimized because of development of advancements in the composite materials, which are structural composites. Our computer tables, all the office furnitures for the houses, the modular furniture is all best example of composite materials. Anti-termite, anti-fire proof, etc., 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 are all composites. Okay, now that means what I'm talking about the end product of the composite materials. Now that end product is layer slide. That means various sheets of placing them one over the other. Okay, like that, then the composite is called as lamellar composite. Now, if the composite is made by taking a sandwich structure, okay, honeybee structure generally they'll say, okay, then the type of composite is called as sandwich composites. That means there are sheets outside on both sides, but the center is filled with a honeycomb structure. Okay, such type of composites are called as sandwiched composites. Okay, our plies and all are the examples. Okay, and that concludes the classification of polymeric materials. Okay, now what are the best examples or applications of these composite materials? Composites have now changed the processing of the individual materials, whether you take metals, ceramics, or the polymers. Now, how polymers are being fabricated now? Fabrication part. Remember, I've told you when individual monomer is polymerized, you'll get a resin. That resin is added with various ingredients like pigments, strengthening materials, lubricating materials, and all. It is called as compounding of the resin. That compounded resin is mixed thoroughly, made into a nice paste or a lump. Then what you are going to do, you put it in an instrument and make it into the end product. Okay, that is called as fabrication. Okay, so the fabrication of the materials has now changed completely with the advent of the composite materials. Why? Composite materials have come into the existence due to demand of the day. I want a product just like my glass or the fibers. I want that to be transparent, okay, just like glass, but I don't want that to break. PMMA is the material. Okay, I want a wood-like structure, but I don't want that to get attacked by fire or by termites or fire resistant, termite resistant. Waterproof, main important property for wood. Waterproof quality. How that waterproof quality is coming into the picture? Because they have made that structure which is a composite material by taking polymeric fibers into the action. Polymeric materials are obviously water repelling materials. Okay, that they'll take it as a filler material or dispersed material, and they'll make the all modular furniture. So glass is replaced by PMMA composites, and wood is being replaced by the polymeric materials which are water repelling. Obviously, organic compounds doesn't suffer corrosion. They are fire. Obviously, they are thermal and electrical insulating materials. So, no fire hazard is not there. No termite attack, and hence is the discussion. PVC is very commonly used for the purpose. UPVC they'll see. Okay, and that is the advantage of composite materials. They have revolutionized the fabrication of materials. Okay, so applications right from our smallest of the smallest things which we are using in our day-to-day life to the aerospace technology, the bodies of the aerospace industry, automobile industry, and all the industries that are happening today are all composite materials. That's it. That's a thing. So I'll write advantages. What is commonly asked is classification. Okay, what all flowcharts I gave with you, that is what, and they'll ask advantages and application. So what is the first advantage of composite materials? What you can summarize? ఏమిటి అసలు ఒక్క క్వశ్చన్ కూడా అడగలేదు, నా మానాన నేను లెక్చర్ చెప్పుకుంటూ వెళ్ళిపోతున్నాను. అసలు ఏమైనా అర్థమైందా? చెప్పండి. ఏమిటో ఎస్ మరి